So this is in general just a review of everything here. Okay, yesterday in class we went over the front page of this review. Again, this is a pretty good mixed review. Like question like number 2 and 4 and 5. That's not really in this chapter, but it's just good review that you always need to know in any section that we do. Okay, the other ones though are all pretty straightforward. Any question on here in particular, as you looked over it, that you would like me to go over from this review paper? Yes, sir. 12C. So let's look at number 12. Number 12, we said it was a very important question. Make sure we know what's going on. Okay, 12 gave us this implicit, and it asked us to do some different things. Implicit has become a very common free response question on the AP exam. Okay, so this would be an example of what they could do. Part A, they made you show the derivative. So that's just getting dy dx by itself. They told you the answer. All you have to do is make sure that it's true. Part B said write an equation of the tangent line. So that one's pretty easy as well. It's just plugging in the point they gave you and then finding the slope by plugging it into dy dx. The third one says find the coordinates of the 2 points on the curve where the line tangent to the curve is vertical. Show me with your arm, what does a vertical line look like? If you're tangent to this, it means it's the same. What would the slope be of a vertical line? It's undefined. Okay? So based off of this derivative that we have here, if we are undefined, what is going to be true about that fraction if I'm undefined? The bottom is 0. I don't care what the top is. I want the bottom to be 0. That's when I'm going to get a vertical line. All right, so as I look at this problem, I took the bottom and I set it equal to 0. Once I solved that, I divided by 2, I subtracted 1, I cube rooted. Y is -1. Okay? It said find the coordinates of the 2 points on the curve. So -1 is going to be my 2 y values. I'm going to find my x values. Right now, it might not seem clear as, hey, how am I going to get 2 x values? But I will. I took that y value and I plugged it back in to this initial equation because it's going to get me x. Okay, so I plugged it in here. So everywhere I have a y, I plugged in -1. And when I do that, I get this thing right here, which is a quadratic. I'm just going to make it equal to 0. So I moved the 5 over, I subtracted the 4 and the 1, I get -8. Then to finish that, I solved that quadratic, I factored it, I got -4 and 2. Those are the 2 x values to go with them. That's going to get me my 2 points. If I were to plug those 2 into my derivative, I would get undefined slope. Therefore, it's got vertical tangent lines. Jake, kind of makes sense what's going on there? It's a different one. Okay, but that's something important, and I would make sure I would understand, at least in general, how we did that. Other questions? What else on this review are you not sure about that you'd like me to go over? Anything at all? Number 9. Number 9, we're finding the derivative. 4 cosine y equals 3x squared plus 5y. Okay, I started off by finding the derivative. Okay, so 4 cosine. 4 is a constant, so it's going to hang out. Then I took the derivative of cosine, which is negative sine. I rewrote the baby, and then I had to multiply by the derivative of the baby, dy dx. Okay, on the other side, I get 6x and 5 dy dx. I've got multiple dy dx's. There's a dy dx, there's a dy dx, so I had to get those things on the same side. So I left this where it was, and I moved this 5 dy dx over to make it negative. Then we said, all right, I've got a dy dx in both of them, so I had to factor it out. And I was left with -4 sine y minus 5. And then to finish that thing, I divided by -4 sine y minus 5. Don't forget to factor. You got more than one dy dx. If you can't combine them together, we factor it out. Yes, ma'am?
Can you kind of explain this to us yesterday? I don't understand. It's like EDX, when we take the second one, you have to redo the baby again, right?
Yeah, so it's e to the 4x squared. I took the first derivative. So the derivative of e is what you see times the derivative of the exponent. The derivative of the exponent is 8x. Okay? And so once I've gotten that, now I need to find the second derivative. This is going to be a product rule question because this part and that part both have an x in it. They're being multiplied and I have an x in it. So then I did first times the derivative of 8x, which is going to get me 8, plus the second, which is 8x, times the derivative of the first. So the derivative first, the derivative of that e to the 4x squared, the derivative of e is what you see times the derivative of the exponent, which is 8x. Okay? I think you're wanting to go one extra step and take another derivative. You don't need to do that. Take the derivative of e and then just look at that exponent and say, I'm taking the derivative of the exponent. It's 8x. I'm done. Other questions? Anything else on that review that you want me to explain? Yes, ma'am. What's up? Three? Okay, I just couldn't hear the number. You're fine. Okay, number 3. X squared y plus y equals 2x. We are taking the derivative. On this first part, I've got a product rule because I've got x squared and then I've got y, two things that are being multiplied. So I said first is x squared. The derivative of y is dy dx plus the second, which is y, times the derivative of the first. Derivative of x squared is 2x. Then I've got the derivative of just y. The derivative of just y is dy dx. And then it's all going to be equal to simply 2 because it's the derivative of 2x. Good on the first part? Once I've taken that derivative, all I need to do at that point is plug in. Everywhere I have an x, I can plug in the number 2. Everywhere I have a y, I can plug in -1. You could get dy dx by itself if you'd like to. But I always think it's easier to plug in. When I plugged in, I've got 4 dy dx's. I've got another one right there, so I've got 5. If I moved this -4 over, then I would have 6 on the right side. Divide by 5 dy dx. That'll give me my answer. Other questions? Anything else on this review? Yes, ma'am. Number 7. We've got two things being multiplied. It's 2x times arc sine x squared. So it might be important to think, hey, that x squared is in parentheses. They didn't put that there, but that is in parentheses. We are using product rule because it's two things being multiplied. So it's first is 2x. The derivative of arc sine is 1 over the square root of 1 minus the baby squared. Okay, all I have left to do is plug in the baby. In this case, the baby is that x squared right there, times the derivative of the baby. The derivative of x squared is 2x. Okay, and then the rest of it's simple. Plus the second, I just wrote the second again, times the derivative of the first. Derivative of 2x is just 2. All I did there from there was simplify it, but that's the main idea. Yep. Any other questions? Anything else on this review? I gave you a related rates review. Okay, you didn't have to get to that yet. Maybe you saved it for tonight. Anybody get to that related rates review and want me to go over one? Rachel?
Can you just go over the proportion one? I think it's the third.
Yes. Sven, who is 1.6 meters tall, walks away from the base of a 4.5 meter lamppost. So I got a lamppost. It's 4.5 meters. Sven is 1.6. He is walking away at 1.2 meters per second. At what rate is the length of his shadow increasing? So here's the light. Here's going to be his shadow. And now I would say that on the AP exam lately, they always kind of give you a picture on related rates. They don't make you think it through unless it's just a basic shape. But for the most part, they give you a picture. I would think they would give you a picture here. When he is 6 meters from the lamppost. Okay, so we'll call this x equals 6. This is dx over dt. We'll call his shadow y. We are trying to find the rate his shadow is increasing, so I'm looking for dy over dt. Understand the setup there? It's a light post question. We know it's similar triangles. I've got a big triangle, this guy right here, and then I've got a smaller triangle. That's this guy right here. So if I'm setting that up, the big triangle, the thing that I want to know is the bottom side. Okay, so on the big triangle, I've got 4.5 is the left side, and the bottom would be what here? X plus y. We don't want to say 6 plus y because that 6 is changing. Okay, because the distance from the guy from the pole to the light is changing. So this is a variable 6. This is y. X plus y is going to get me the whole bottom. That's going to be all equal to this purple triangle. The purple triangle, the guy is 1.6 meters. That is in relationship to the 4.5. That's not changing. And the bottom side is the shadow, which would be y. That's my setup. X's and Y's are changing. There isn't anything that's constant. So I'm going to go ahead and simplify. So I'm going to cross multiply here. So 4.5y equals 1.6x plus 1.6y. I'm going to get the y's on the same side. So minus 1.6y. 2.9. I did all of that to now take the derivative. I did all the hard work. Now I can take the derivative. So this is going to be 2.9 dy over dt, which is what I'm looking for, is going to be equal to 1.6 dx over dt. And I know what dx over dt is. It's this 1.2 because that's how fast he was walking away. That's going to be a positive number because he's walking away. And so right here, I can plug in 1.2 and then divide it by 2.9, and that will give me my answer. That one's tough.
Yeah, I like did it just because I copied what we did.
Yeah. And that's okay. I would say that's okay. You don't have to be an expert at that. If you're just saying, hey, that one's tough, it's okay. It's not one that's going to be worth 400 points on the test. If there's a lot of stuff on there. Questions here? Anything else on this related rates packet? Good. Let's go to Bellwork. A balloon is rising vertically above a level straight road at a constant rate of 1 foot per second. Just when the balloon is 65 feet above the ground, a bicycle passes under it, going 17 feet per second. How fast is the distance between the bicycle and the balloon increasing 3 seconds later? Okay. So, let's label some stuff. The balloon is rising vertically at a constant rate of 1 foot per second. So, we're going to call that H. Everybody okay with me saying H? So, this is H over here. Okay. dH over dt is going to be 1. The bicycle, I'm going to call this B, just standing for bicycle. The bicycle is going under at 17 feet per second. So the change in bicycle over time, positive 17 or negative 17? Positive. It's getting further away from the balloon. This is a positive 1 because it's getting further off the ground. How fast is the distance between the bicycle and the balloon increasing 3 seconds later? I hate that they put the 3 seconds later. We'll deal with it though. Okay. What is the B going to be on this problem? Well, actually, let's do this. I'm looking for this. What do we want to call this missing side? Y. Somebody said Y, so we'll call it Y. Okay. I don't know why we called it Y, but we did. That's Y. I'm ultimately looking to figure out how fast is the distance between the bicycle changing. So I'm looking for dy over dt. That's the mystery number. What is the bike value going to be? What? 51. Where are we getting 51 from? 17 times 3 is going to be 51. That is B. Okay, because it's 3 seconds after he passed underneath. What's my H going to be here? It's 68. Stupid, but do we understand why it would be 68? He's 65 feet, the bicycle passes, and 3 seconds go by. I've never seen them ask this question just like this before, but understand what it was. He was at 65, 3 seconds go by, and it's going up at 1 foot per second. We want to know at 3 seconds later, so we want to know at that time it's going to be 68. It's mean. Deal with it. We'll be okay. Everybody good to that point? I've got a right triangle here. I've got two sides of a right triangle. I'm trying to find the third side of a right triangle. What formula do we know that's going to relate three sides of a triangle? Pythagorean theorem. So for us, we're going to say h squared plus b squared equals y squared. Oh my gosh, that's a hot mess. But that's all right. H squared, b squared is y squared. Is h changing? Is b changing? Is y changing? Everything's moving. No constants. So we're going to take a derivative. 2h dh dt plus 2b db dt equals 2y dy dt. Everything's got a 2 in it, so I'm just going to divide everything by 2. That way I don't have to mess with all the 2's. I divided everything by 2. They disappear. We plug in what we know. H is 68. dH dt is 1. B is 51. dB dt is 17. Y is, I don't know. And dy dt is, I don't know. How do I find y? Pythagorean theorem. We're going to do Pythagorean theorem. We want to find this missing number, so we're going to go 68 squared plus 17 squared equals y squared. 68. 68 squared plus 17 squared. Question? Oh, it's 51. Where am I getting? Yeah. Don't ignore what I just said. 68 squared plus 51 squared, because those are the two distances. My fault. 68 squared plus 51 squared, 7,225. That's not what y is. What do I need to do with that? Square root it. So I'm going to take the square root of 7225. So in my calculator, I'm taking 68 times 1 plus 51 times 17. And I'm going to divide that by the square root of 7,225. That's just moving stuff over. I combined what was already over there. I started off by adding these two things together. I divided by the square root of 7,225. I hit enter. 11. Did not see that coming. It was 11. 11. What would my units be on that thing? Feet per second, because it's a measurement over time. It is the distance between them over time. 11 feet per second. Questions there? So I'm just going over this quiz. I'm finding the ones in particular that we aren't great at, and we'll see if we can fix some things. Okay, this one in particular is a little bit weird. We did that on Friday's Bellwork. You find the derivative of the first one, you get dy dx by itself, and then you solve for the second one. A little bit more challenging. I'm not going to spend my time right now looking at it. Go back on that. I did on the backboard back there, but I'm not super concerned. I know we might have missed that one. We are good at approximating that one. This one makes me a little nervous. Okay, bless you. This is one you need to know. So let's look at it real quick. Okay, this should be one that we should be more like 100% on than what we are. Sorry, it just kicked off on me. Oh, come on. All right. So it says a tank is being filled with liquid. The function, oh, come on. The function V gives the volume of the liquid in the tank. What is the best interpretation of the statement? The derivative of V at 1 is equal to 2. Okay. What is V? That's what I'm looking at first. What does V represent here? The volume. So if I'm finding V prime, the derivative of V, what am I finding? The volume change. Okay. The volume is a rate. So this one right here, I don't want at all because it says nothing about a rate on that second one. Okay. T is time. So after 1 minute, do not ever use during. Okay? If you see during, if you see over a 2-minute interval, bad. It's either at t equals, or here you can see they used after 1 minute, because that is after 1 minute is gone, now we go. Okay? So it's either the first one or the third one. Okay? I was started in liters and I found the derivative. So what are my units going to be now? Liters per minute. It would be the third one. 3 out of 9 is not good enough. If you miss that one, you need to jump on Khan Academy, okay? Or Schwann Academy, it'll be a link to it. 2.8, that section, click on it. It's in there. I linked it in there, okay? That's interpreting derivatives, okay? Because we missed this one just as poorly, okay? If you're missing that, you need to go back and look at it. Look at those notes, okay? This one. I know it's a little bit weird, but in general, think of delta x like h. What are you taking the derivative of? Arc sine. The derivative of arc sine is 1 over the square root of 1 minus x squared. The answer is C. Okay, that is just another question. That's a disguised derivative of, hey, it's arc sine. You need to know the derivative of arc sine. That's basically taking two of our problems, putting them together. On this one, again, h approaching 0. All right, cool. I'm finding the derivative of cosine of x. Notice that there's no numbers in this one. They just use the letter x. Great. What's the derivative of cosine? Negative sign. It's b. Okay, don't let it be hard. Okay, on this one, I'm taking the derivative of e to the 2x because it's 4 plus h, and your x is going to be 4. Okay, take some time and do those problems. I put a bunch of them on there because I know that we might struggle with them. That's where I wanted to put our focus. You have